see that the retina is going to thin out. Oops, got out to the muscle. Okay, right about there. We're losing the retina. Okay? Not quite. We've got a little bit of destruction there. We still have some retina there. It's shorter. We have some destruction here. All right. Retina's still going. We have what's happened here, and I'm just going to interpret this for you because it's odd. The choroid coat in the section has been moved out of where it belongs. But we are getting anterior. And I went around the other edge of an eyeball, or had a different slide yesterday. So I don't like that. I'm going to go across the eye right now. All right, so right here, we've got disruption of the choroid layer. Okay, it's separated as an artifact right here. Nonetheless, you can see the retina thins and ends right here. Okay, so we're near the front of the eye. Yes?
Can you do that part of where the retina ends? I missed it, looking back for it.
So here we still have rods and cones, bipolar cells, and ganglion cells. And watch these layers. As we go this way, I have to go just a little bit farther. That's the last of the rods and cones, the last of the bipolar cells, the last of the ganglion cells. The retina ends right there.
The big pink part is the big white pink part is the choroid?
This?
Yeah.
This white is an artifact. It should not be white. This choroid layer should be smashed, and we're starting to pick up smooth muscle cells here, and so we are getting to the region of the ciliary body. So that middle layer, the pink that's coming in, is smooth muscle, and this is forming the ciliary muscle of the ciliary body, and I should probably be at a lower power. I'm sorry. Makes it look not quite so huge. So the smooth muscle coming into the choroid layer with these processes, that's all part of the ciliary body. And it is a development of the choroid layer. It's got smooth muscle, it's called ciliary muscle. These are called ciliary processes. And attached to these outies, or ciliary processes, are suspensory ligaments. The suspensory ligaments don't section well because they're tiny bundles of collagen fibers. We come over from those sensory ligaments and they are suspending the lens. Okay? The lens is crystalline protein. When it's working right, the crystals are all lined up and light passes through, and the lens changes shape because the ciliary body has muscle in it. It can contract, pull on the lens and flatten it, or it can relax and let the lens ball up. That's how you go from near vision to far vision. Shelby?
So does that mean it's not fully with crystallizing it? Mean it's completely hard
No.
in your eye? Okay,
No.
so it is.
It's living, it's protein, it has to be maintained, it's crystallized. What happens in a cataract is you lose some of the organization and it can harden, and then it can't accommodate change, and then they often do a lens replacement surgery. Okay. So we come across the lens, and there's the other pointed end, and on this side there's our ciliary processes and ciliary body. Okay? So I don't know what name am I using here for you. Ciliary body, okay? And I've got it described what that is. Now, as we come forward of the ciliary body, we find one more projection which is quite large. It makes a shelf. And that shelf comes forward in front of the edge of the lens, and if you're mid-sagittal on the eye, it ends at the pupil. But because we took a parasagittal section, because they did, that's what they sold us, the iris, we caught a part of the iris where it's going all the way across the lens. So we're just on the edge.
Sorry, show me
Of the
what that
iris.
part of the iris is.
So this is iris, and now watch it as I move it. It's going in front of the lens, and we keep going. So we miss the pupil. The section is too far to the side of the pupil.
So if the pupil was on this, would you see a cut?
So if the pupil was on this, we'd see the iris come to a nice point. We'd see nothing in front of the lens for a while, and then we'd pick up the iris on the other side. Okay? Now, we're in the anterior cavity here. Don't be confused if you're looking at pictures and they talk about chambers. There is an anterior and a posterior chamber to the anterior cavity. I don't make you differentiate them anymore. And we come forward of that, and here, if we came up from the side, here's the ciliary body, and here's the sclera, the fibrous connective tissue. As we follow the sclera anteriorly, it gets organized and becomes transparent and bows out with a different curvature in front of the lens. So that's the cornea. Okay? Now, on this particular slide, I think in places the palpebrae or eyelids are showing. But I want to show you the cornea. It has a thin layer of epithelial tissue, has epithelial tissue on both edges, but this front edge is called the conjunctiva. And if any of you have ever scratched your eyeball, you felt pain, and that's a highly innervated epithelial membrane that's protecting your cornea. It is stratified squamous epithelium, and when you scratch your eyeball, you're disrupting that membrane. Okay, so you're triggering the sensory nerve endings, but the pain goes away in like 2 to 3 days because the epithelial cells replace very quickly and the conjunctiva heals. Okay, so that's a layer of the cornea, the conjunctiva on the anterior surface. And this stuff out here is just part of eyelid that they got on the slide that I'm not covering. Okay, so I would tell you the light enters the eye here. Okay, so that's the last of the sensory organs, the part that you have to know histologically. And I do believe that's on